So this one wants us to do toothpicks again to find slopes and all that. But we're not a private school that has tons of time to do everything. So that's kind of what this was made for. Do you guys know what block schedules are? I don't know if you have any friends in other schools with different kind of schedules. We do 6 periods a day, trimesters, which is pretty unusual. And because of that, we have 54-minute classes or something? A lot of schools have a schedule that gives them like an hour and 20 per class, or an hour and a half. And that's kind of like called a block schedule. You're bringing back more calculators than I hate.
I can't remember which two were yours. Two,
Oh,
three, I'm
a
sorry.
blue one and a yellow one.
Perfect, thank you.
So the reason I say that, this is the exact same setup as before. It would take us forever to do this. It's a worthy thing, but it doesn't actually help you understand how to do it any better. So. Let's start with number 1 at least, because I can kind of help us go from there. Jihu, did you call in anybody?
No.
Okay, good. Wait, did you say Arjun?
Arjun.
How do you pronounce it?
Arjun.
June, okay. I just wanted to make sure I wasn't saying it wrong all year. What does e to the x look like? Oh,
Is it like a parabola?
it's not, that would be squared.
Yeah, is it like an exponential parabola?
Yes. It's like half a parabola-ish. Yeah, they don't actually match up to half a parabola, but that's somewhat the shape. So e to the x, it's gonna be exponential because it's got the variable in the exponent. And it goes through the point 0, 1, like just about every exponential. If I put a big number in place of x, the answer would be huge. So over on the right hand side, it goes up. If I put a very small number in place of x, like -10, I mean, that's not even that small, but if I do e to the -10th power, that would technically be 1 over e to the 10th, which is gonna be 1 over a really big number. And so it would be a tiny answer. The only reason I'm bringing that up is that tells me that it is going to be very small over here and take off to the right. So if I know it's exponential, I just need to know which way it's pointing. And so you plug in numbers in your head to figure that out. Okay. Does anybody have Desmos open? You have it open? Did you put e to the x in already?
Yeah.
Excellent.
Also put in for your bit, that helps.
Yeah, we don't, no, it doesn't. I mean, it would, but, what, can you just move the, I don't know, move the mouse will help. What are these approximate answers really quick? Actually, I got e to 0. What is he gonna get? Is that a 2.7? 2.7? Those are the only two I know.
B, I have it B of x equals B of x. B of 2 is 7.389.
My brain screwed that up. 7 point,
389.
let's go with 10.
Okay. And then B of 3 is 20.1.
1 over 2.7, whatever that is. It's like a third.
0.367.
So again?
0.36.
They said 3.3, I'm like, no.
0.1. 0.04.
Thanks. Okay, I mean, E is a weird number. It's not like anybody's just gonna know these answers off the top of their head. But here's the really nice thing and really super easy part, is if I would actually take the toothpick and measure the slopes, here's what I would find. So, our June, who do we got? Wait, Devin, you're here, said you were gone. All right, nice. We'll go with Devin. If I notice that pattern, what is gonna be the derivative of e to the x?
E to the S.
Correct? It's your favorite derivative of all. It's the weirdest one because every single slope at every x value is the exact same as the height of the point. If you get to the spot where there's a height of 8, the slope there would be 8. It's very strange. It's the only equation that does that. And it's just kind of saying, it's one of the reasons it's considered the natural number. It's the easiest one. Everybody here is gonna love it. Every time you see it on a test, you're gonna love it. Cool, I'm gonna skip all the rest because that one is super easy. Wait, is one of the X on the bottom? My fault. I forgot ln of X is down there. The graph of ln of X, if it helps, is the inverse of exponential. It's a logarithmic graph, which would go through the point 1, 0 instead of the point 0, 1, and look like that. So the first thing we have to realize is that no negative numbers, no negative x values are possible or can be used. Okay? So if our original graph has the domain of just positive numbers, then my derivative has the same domain as well. I don't think we've run into that in any of the problems so far. ln of 1 would be 0. Does everybody got a calculator open? I'm not gonna pretend to just know these. Do you already have that one in too?
Yeah.
You might as well just teach this class. I don't like that you're more prepared than me.
H of 1 is 0. H of 2 is 0.69. H of 3, 1.09. 1.38.
Yeah, pretty much all close at that stage.
1.60. 1.79.
Thank you. Okay, so, again, come on. I could go through and try to measure the slopes everywhere. Here's what you're going to find for the slopes. So those are all the slopes at those locations. And that one wouldn't have been as obvious. So like you would have probably done slopes as a decimal or something maybe. I doubt you would have measured it like 1/2, 1/3, whatever. But maybe you would have done rise over run and got it pretty close. My guess is you would have had 1, 0.5, 0.33, whatever. I don't remember where we're at. We're at Devon. Devon, I need somebody to tell me this info. So, if the original function is ln of x, Barbo, what would be the derivative given those answers? Otherwise, I can give you some guidance. Sounds good. At x equals 2, the derivative is 1 over 2, and x equals 3. The derivative is 1 over. So the equation should be perfect. 1 over x. The derivative of ln of x is 1 over x. So you will find the, do you guys want me to scroll that up higher if I can? I don't know, if maybe you can't read it. Go ahead.
Why is G, why is, the G prime of x, why is 1 at x equals 1, why is it 0?
G of x is 0, but G prime is 1. Is that what you said?
But the x is 1, and if the differentiated version of
So if I look at x equals 1, the height is 0, so that's the original function answer, but the slope would be 1. Is that what you were getting kind of backwards on or whatever? Okay. Now I forgot what I was gonna say, but that's okay. Oh, yes. Power rule, you're probably gonna find the easiest to use because it's just simple. You know, you multiply in the front, you subtract the power. But the trig derivatives, and they have a terrible name for these, so we're just gonna call them the other derivatives. So these derivatives, you essentially just have to memorize what the derivative is. And I know that sounds horrible, but right now, it's going to get a lot worse. Because there's just like a zillion things to memorize this year. And to me, that's one of the most difficult parts of Calc. Because you guys generally are pretty good at learning a new idea, new concept. But there's just a lot of things to remember throughout the year. So we're gonna do our best to try to ease you into that memorization. You're not gonna be expected to memorize everything right at once. What happens is the more you use them, you naturally memorize them. So we'll try to figure out, you know, for like the Unit 3 test or Unit 2 test, if we should put some formulas up on the board for you or something so that you don't have to have everything memorized. We'll try to figure out what would be kind of fair. Essentially doing the problems just requires that you know all of the memorization. And the more you can memorize, the quicker they go. If you would like to write in the quick notes, this is the derivative of e to the x is e to the x. And then the derivative of ln of x, so that's log base e, is 1 over x. I don't know, can you, I did just realize I don't even have it turned.
Yeah.
I can read it good enough.
Mhm.
Are you even looking at it?
Yeah. Do you over X?
How about the common algorithm? The derivative of a common algorithm?
You don't wanna know that one yet. It's actually harder than natural log. Not a lot harder, it's just more formulas to memorize. Okay, let's do a couple problems together, but I feel like you probably are gonna be okay with them. Phoebe, can you help out with number 1? So we've got f of x, and let's do the derivative of each part separately. So that's kind of how your brain should approach this. You look at each one separately, don't look at it as a whole because that feels overwhelming. So derivative of e to the x.
E to the x.
Nice, okay, good start. Derivative of 3 times x,
Just
3, plus derivative of ln of x.
1 over x.
Nice. Okay, now if I'd given you that equation at the beginning of the hour and said find the derivative, it looks like it should be difficult because it's got weird parts to it. But the derivatives are not difficult, it's just memorizing. Okay, now it actually wanted us to find f prime of 3. So that just requires us to plug in 3. So I'd have e cubed minus 3 plus 1/3. I'll let you simplify it however you want. The one way you should not simplify is turning it to a decimal. So the decimal answers are generally specifically saved for calculator allowed questions. And generally when you are supposed to use a calculator, the problem starts off with decimals most likely. So usually that's kind of the general rule of thumb. If a problem starts with decimals, it's usually okay to work with them throughout. If it starts with nice numbers, well then that generally wants an exact answer. Okay, so -3 plus 1/3 would be -2 2/3. I don't care how you want to write that. You could do a mixed number, you could do improper fraction, they're all correct. But those two don't combine together in any which way, so we don't. We just leave that as the answer. Okay, Phoebe, we need somebody who knows about horizontal tangent lines. I don't know who that is, but you do. You call it Abigail?
Yeah.
Wow, she is so appreciative. Okay, Abby, guide me. Otherwise, I can give you some guidance if you want.
Can you start me off?
Yes. Okay, so I'm not even gonna worry about the horizontal tangent part yet, but the fact that it says tangent line tells me derivative. And if you are totally lost, FYI, for the whole first half of this class, just know you're gonna have to take the derivative. So if you're very lost, it's gonna be involved. Okay, so y prime, what is the derivative of e to the x? Good. Okay, oh, oops, come on. How about the derivative of 4?
0?
Correct? So this is my whole derivative. Now, was the horizontal tangent line the part that kind of threw you off a little bit? Okay. Horizontal means slope of 0. So it's asking us, where does this original function have a slope of 0? And if we're trying to figure out where the slope is another word for equals. Slope equal to 0. E to the x equal to 0. But who do you want to help solve this? They're going to love you for it. Kaylee? She loves you for this. Help me out.
I would like some guidance.
Oh. Guidance is we're trying to figure out a number to put in place of x that makes that
Oh,
true.
just any.
Or are you asking me how to go about solving it?
Yeah.
How, do you remember how to solve for an exponent? So that's the logarithms.
Okay.
The whole point of logarithms is to solve for the exponent. I believe, I don't know about AP Pre-Calc. I know regular Pre-Calc always taught everybody to take the natural log of both sides. Is that what you guys did in AP Pre-Calc? Okay. So you would take the natural log of both sides to try to solve this. I did that. It is not. ln of 1 is 0. You're thinking correctly, you're just doubting yourself right now, and I can tell. Do you want me to show you the graph of natural log again?
Yes, please.
This is what I picture in my head most of the time when I'm trying to solve things that aren't making sense to me. Okay? What would ln of 0 be? the search to anybody?
Yes.
Can anybody help Kaylee out? Cause they're, I'm pretty sure they're just as, at the same spot as you. Somebody who has an answer possibly?
The slope is always increasing, there's never over the zero.
Wait, say it again?
Technically, it's at infinity, because the slope's always increasing.
You're kinda right. ln of zero is not a thing. You're not allowed to do ln of zero. And so at this stage of the problem, you actually don't even have to finish, because ln of zero isn't an answer. It's undefined. So natural logs can only have positive numbers. So zero is the positive. Normally, what you would do is the power on E would go in the front, and you'd say x times ln of E, which ln of E is 1. And so, what the heck? What does it do? Oh, yeah, yeah. Wait, no, it's up there still. Huh. All right. ln of zero is not a thing. So normally you would just take that answer divided by ln of E, which is 1. This doesn't have an answer. So that's why this question, if you read it, is phrased, for which x values does it have horizontal tangents? And then we would say nowhere. I mean, I would say nowhere, but whatever. So there are none, no x values. Have a slope of 0. I think that's what you were trying to explain from the beginning when you said it's always increasing. If you look at the graph of ln of x, it never is flat. The closest it would get to flat is actually a really big number. Okay. Oh, I'm sorry, it was e to the x, not ln of x. But still, e to the x doesn't have any slopes of 0 either. Looking at the bottom ones, do you want to do one of these together? I know we don't have time to do all of them, so I'm not gonna do all of them, but any one of those look confusing to you that you feel like we should do together? You're lying if nobody says anything. Alyssa, which one should we do? What looks confusing to you?
5.
5? Oh, you got it right to the left. In the xy plane, the line negative 3x plus 9y equals k, where k is a number, constant, is tangent to the graph of y equals ln of x. What is the value of k? Oh, I don't even know if we're gonna have time to do this one. This one's got multi-steps. So, we essentially want to know, when does this become a tangent line to that graph? And that would require us to solve, oh boy. Should I explain how you would do it? I'll explain how you would do it, but I was hoping to give you guys a little bit of time to be able to turn in homework or ask questions or whatever. Let me try to move it down here. Okay, so first thing I would do is I would start with the fact that the original function and this line are going to share in an x and a y value. So they would be equal, the height would be equal at some x value. So I would start off by making the two things equal. Now that would require me to solve it for 9, or solve it for y. So if I rearrange this, divide by 9, I'm going to set ln of x equal And that would find me the X value where they would be the same. Now, the next part deals with the slopes. Because the slope of this line would be equal to the slope of this equation. So y prime is 1 over x. Can anybody tell me how I would figure out the slope of that line? So it's clearly not written in slope intercept or point slope form. But if we rewrite it as slope intercept form, we'd be able to figure out the slope. It's actually pretty close to the slope intercept form right there. What's gonna be the slope of this line? 1/3. It would be 3x over 9 plus k over 9. So that reduces to 1/3. And so my derivative Emmanuel, give me the super easy answer now. What x value would they have the same slope? 3. We'd solve the bottoms. 1 over x is equal to 1 over 3. Well, x is 3. And so then that would tell me the x value where they share the same slopes. And then I could take that x value, plug it in the y original function to find the actual point if I'm looking for that. But this one wanted the k value. So you would use x equals 3 to figure out the k. I guess that actually was a lot quicker than I was anticipating. I felt like it was gonna take us like 10 minutes. Okay, why don't I stop there? Just because I wanna give you some time to ask questions. So the people who started the homework on 3.5, if they wanna come ask questions, cause like I said, I heard some of them were kinda difficult, you're welcome to. I attached the answer key to 2.4 to the homework yesterday. The homework for 2.5 is due Sunday. I believe the homework for 2.6 is like Monday or Tuesday. I don't know, I wrote it in Schoology. But the plan is next week that we would pretty much finish the unit and then take the week after that to get ready for the test. So for those of you who are busy with things, this entire year is gonna feel the same way, where it feels like we're just chugging along, never stop, never pause. And that's because we can't. I wish we could. But northern states kinda get screwed out of the AP test because southern states generally start school at the beginning of August. And so the AP test is at the end of their school year. Most northern states start right about September. And so we have a month of school after the AP test. So we essentially get chopped out a month of school to try to get ready for it. And so we don't have time to slow down and review. We don't have time to slow down and, take time for your brain to absorb info. I wish we did because I would like it. I don't like the way the class has to be set up, but that's not my choice, to be honest. So we do what we can to get you ready for the AP test. And I know not everybody's taking it, but the class is geared toward it, so we plan the class for it. Okay, we got like 10 minutes, 10-ish minutes. I'll gladly help you with whatever you want help with.